Hello, we're going to be talking about STA2023, Statistical Methods, Chapter 6, Section 2, the Normal Model. We talked about this in Section 3.2, so if you want to go back and look at more examples to kind of give you a heads up for this section. In this case, we're looking at normal curves, and we're looking at the method using z-scores. Remember, z-scores is a standard unit, measures a value relative to the sample rather than respect to some absolute measure. And so we have a z-score formula. Remember, it's x, the observation, minus the mu, population mean, divided by standard deviation. So to give an example of that, find the z-score when the average length of a football game is 180 minutes and the standard deviation is 20 minutes. What is the z-score when you're looking for a time of 210 minutes? So our observation would be 210. Our population mean would be 180. Our standard deviation would be 20. So to find our z-score, it's 210 minus 180 divided by 20. Be careful, practice this. The entire top needs to be in parentheses. And you should get 1.5, and we're going to put 1.50. When using the tables, we need 2 decimal places. So remember, in this case, we're using the tables. There are other tables you can use. There's a calculator. There's many ways of finding this, but I'm going to show you using the tables to kind of get the concept down. So we have our negative z table, and we have our positive z table. So let's do an example. Remember, the z-tables always tell you to the left, less than. So, the distribution of a length of a football game is approximately normal with a mean of 180 minutes and a standard deviation of 20 minutes. What proportion of all football games are less than 150 minutes long? So, step one, we're looking for less than 150. Remember, we've done less than, more than, in between. This one's looking for less than. So, we find our z-score. 150 minus 180 divided by 20 should give you negative 1.50, 2 decimal places. Remember, this is our normal curve. 0 would be in the center, 1, 2, 3 standard deviations to the right, negative 1, negative 2, negative 3 standard deviations to the left. Since we have negative 1.5, that would be to the left 1.5, and we're looking for less than, so we shade less than. So we're going to look up a z-score of negative 1.50. So I go to the table, the negative table, negative 1.50. That gives us 0.0668. And remember, the table always tells us less than. So we're looking for less than. The table gives us less than 0.0668. So our percent would be 6.68%. Now we always stop and double check. Remember, the entire curve is 100% underneath, and this was a small portion. Our answer is small, everything checks out. So the proportion of football games that are less than 150 minutes is 6.68%. Next question. What proportion of all football games are more than 165 minutes long? This time we're looking for more than. So we do 165 minus 180. Divided by 20, be careful, you should get negative 0.75. Negative 0.75 would be on your left here, but remember, we're looking for more than. So I shade more than, we have a large percent. So I go to my z table, I look up negative 0.75, negative 0.7, match it up with the 5, gives us 0.2266. But remember, the table always tells us less than. So we get 0.2266, but that tells us less than. We want more than. And again, this does not look like 22%. So we have to subtract from 100. 100 minus 22.66% gives us 77.34%, which makes sense. Picture, answer, match. The proportion of football games that are more than 165 minutes is 77.34%. So we did less than, we did more than, now we're going to do between. So what proportion of all football games are between 130 minutes and 230 minutes long? So because we have two values, we have to find them separately. 130 minus 180 divided by 20 gives us negative 2.50. 230 minus 180 divided by 20 gives us positive 2.50. Now it's interesting that we got the same number, just one negative, one positive, and the reason for that is the same distance from the mean. One's to the left, one's to the right. So negative 2.5 would probably be a little further down here. if we want to be a little more accurate, and positive 2.5 a little further down here, but we're looking for everything in between. We're looking for everything in between. Then we go to the table. So negative 2.50, negative 2.50, negative 2.50 gives us 0.0062. Remember, it tells us to the left. Positive 2.50, positive 2.50 gives us 0.9938, again to the left. So picture-wise, from here to the left is 0.0062, not shaded. From here to the left, 0.9938 is shaded and not shaded. So if I just want the center, I would take these two numbers and subtract them. So 98.38% minus 0.62% is 98.76%. So the proportion of football games between 130 and 230 minutes is 98.76%. Large shaded, large answer, everything matches. Now the next two can be a little confusing, so I'm going to try to explain them as best I can. And then these two are a little confusing because it asks for what time. In all the previous examples, the time was given. So this is kind of a backwards problem, because in all the previous examples, the time was given. In this case, it's not. So what time has 30% of the observations falling below it? So we don't know the z, we don't know the time, that's what we're looking for, but we know that the average is 180 and the standard deviation is 20. So they have to give me a clue so we can find our x. And the clue is 30% below. 30% below. Now, the z-score is not 30%. Percents and z-scores are two different things. But that's going to help me find my z-score. So if we're looking for 30% below, it would be the bottom 30%. So 30% is 0.30. Remember, that's not the z-score, that's the percent. But we know the z-score is on the negative side. Negative side. So I go to the negative table. And again, I'm trying to find the z-score given the percent. The percents are located here. So we're looking for 0.30. 0.30, not 0.0030, not 0.30. We're looking for, not 0.030. We're looking for 0.30. 0.30. And the closest to 0.30 would be between these two. And this one technically is a little closer, and either one would be fine. But if we choose this one, what z-score gives us that? Negative 0.52. Negative 0.52. Now it's a little weird because we're going backwards. We're given the percent and asked backwards to find the z-score. But the z-score that gives us 30% below, would be negative 0.52. Plug that in for z. Now we solve for x. So to solve for x, we multiply both sides by 20, add 180 to both sides, and we find the time that has 30% of the observation below it is 169.6 minutes. So the time that has 30% of the observations below it is 169.6 minutes. Okay, let's try another one. What time has 22% of the observations falling above it? So again, we don't know z, we don't know x, but the average is 130 and the standard deviation is 20. Now we're looking for 22% above. 22% above. So in this case, 22% above would be here, which means our z-score has to be positive, but the table never tells us above. The table only tells us below. So I have to understand, if I'm going to use the table, 22% above means it's 78% below. 78% below, because remember the table always tells us below. So I'm going to look in the percents for the closest to 0.78 to represent 78% and find that z-score. But again, we know it's positive because we're on this side, on the z. So I'm going to look for the closest to 0.78. As we're going to be very clear, here's the percents, here's the z's. So the closest to 0.78 would be here, but that's not a z-score. That is representing our percent, 78%. The z-score that matches with that is 0.77. Now you may be saying, hey, those numbers are close. They're close, and to be honest, I did it on purpose because we have to know there's a difference between them. This 0.78 represents 78%, This 0.77 represents the z-score. Two totally different things. So we plug in our z-score. Our z-score is 0.77 equals x minus 180 divided by 20. Multiply both sides by 20. Add 180. So the time that has 22% of the observations falling above it is 195.4 minutes. And again, look at that previous section to learn more examples. Thank you.